Hello, welcome to my YouTube channel. My name is Kenneth Langat. I'm going to take you through a sub-module unit in craft certificate in electrical engineering. Welcome back. As I have said, the module unit is applied science. Sub-module unit electrical principles. The expected learning outcomes are, at the end of the session, the learner should be able to explain resistance and Ohm's law, describe resistivity, explain series and parallel resistance, work on some series and parallel resistance circuit exercise. Straight away, we look at resistance. What is resistance? Resistance is the ability of a material to resist the flow of current. That is, resistance is a measure of opposition to current flow in electrical circuit. Resistance is measured in ohms and it is symbolized by the Greek letter omega. Conductors. There are good conductors and there are insulators. So when we talk of a conductor, it is a material that offers very little resistance where electrons can move easily. Examples are copper, silver, gold, and aluminium. Then when we talk of insulators, these are materials that present high resistance and restrict the flow of electrons. Examples, rubber, paper, glass, wood, and plastics. Ohm's law. Let's look at Ohm's law. It says that the current passing through a conductor under constant temperature conditions is proportional to the differences across the conductor. Normally, it is given by the expression V is equals to IR. Let's look at resistivity. What is resistivity? It is a term which describes the resistance of a sample of unit length and unit cross-section. Resistivity of materials is important as it enables the right materials to be used in the right places in electrical and electronic components. Materials like copper and even aluminium provide low levels of resistivity, and this makes them ideal for use as electrical wires and cables, copper often being the favorite. Series resistance. This is whereby current flows through one path. Current is the same through each resistor. Equivalent resistance is equal to algebraic sum of the individual resistances. This is given by the expression RT is equals to R1 plus R2 plus R3 plus R4 plus Rn. The voltage is given by the summation, that is Vt total is equals to the summation of V1, V2, V3, and so forth. That is the circuit diagram showing the resistors in series. Parallel resistance. What is parallel resistance? It is a situation whereby voltage across is the same across the circuit. Current across the circuit is different. The expression for the resistance is given by 1 over RT is equals to 1 over R1 plus 1 over R2 plus 1 over R3. The resistance in parallel are arranged as shown in the circuit. And here is an exercise for the class to practice on the same, whereby 3 6 ohm resistors are connected, A in series and B in parallel, across a 12 volt battery. For each method of connection, find the total resistance and the values of all current and voltages. That marks the end of our session. Your presenter has been Kenneth Langat. Thank you for taking time to go to read this, to watch this video. Click the subscribe button below. Namaste. See you again. Bye.